All right, back with part two of dividing polynomials, and we'll get to an example in a second. But one thing I want to mention is the pattern here. That, like, maybe you notice this, that when I look in columns here, I can see all of the terms that are the same degree are kind of all in a nice column, right? And I can see that there's all the constant terms, and that'll help me make sure that I know what I'm doing here. And each step, essentially all I have to do is make sure that the first thing goes away. X cubed had to go away, the negative 5x squared had to go away, the 29, and that's what I'm deciding to write up here, something that'll make that first term go away. And it will take a little while for you to get used to this, but that's why we have the time in class to work. And that's why I'm doing another example starting right now. So this divided by this, there's my divisor, write it out front of my long division, and I think to myself, what do I multiply by so that when I subtract, the 2x cubed is going to be gone? Well, the 2's line up, all I need is an x squared, and where do I write the x squared? I kind of write it in the x squared column here. So now I think, and I'm not going to write down all these steps over here, I'm going to try and do this without. So x squared times 2x is 2x cubed, just like we planned. That was on purpose. And then x squared times minus x is minus x squared. And then I subtract down. Watch your signs. Negative 11 subtract negative 1. Negative 11 subtract negative 1 is negative 10x squared. And then I bring down the 17x. What's the next thing that I'm going to multiply by so that I get a minus 10? Well, what times 2x is going to give me minus 10x squared? Well, I'm going to need a minus 5 to get to the minus 10, and then I also need an x, right? And then when I multiply, do it term by term in my head, negative 5x times 2x is negative 10x squared. Negative 5x times negative 1 is positive 5x. And notice all my terms are lining up here. All my x squared terms are in this column. All my x terms are in this column. And then I subtract, and I get 12x. Bring down the minus 6. And what number then will multiply by 2x to give me 12x? Well, I see positive 6. 6 times 2x is 12x. 6 times minus 1 is minus 6. And when I subtract, something wonderful happens. I get a remainder of 0. And so then I would say, therefore, if I wanted to, my polynomial 2x, and I'm going to erase that just so it looks nicer. 2x cubed minus 11x squared plus 17x minus 6, that's equal to my divisor times my quotient. And notice that's something else is going on here. If I wanted to, and this is just for funsies at this point, we weren't asked to do this, that factors as a grade 11 or grade 10 quadratic, right? It factors into those two factors. Then, now, if I wanted to, I could graph that, because this polynomial, if this is f at x, that's equal to this thing, and I can see where the zeros are. The zeros are 3 and 2 and a half, and I could graph that using the techniques we've came up with recently. So, geez, we're almost there. Question is where did the 2x minus 1 come from? How do we know to divide by 2x minus 1 so that we would get a remainder of 0? Well, we didn't. We don't know. That's for later. Today is all about practicing this skill, and we're still practicing. So I think we got a couple more examples left. Maybe they'll get a little bit weird on us here soon. Yeah, weird. See? I can see that I'm dividing by x minus 2, and that's not weird. But if I were to write this down like this, it messes up my pattern, right? I got to rearrange terms into descending degree. What does that mean? We're in the way there. box. There we go. That means the x cubed's got to go first, then the x squared, and then the x and the minus 2. But also notice there's no x squared term. So what we do is we add a placeholder. And 0x squared is the placeholder, because if I multiply by 0, it would wipe it out, and then it would be gone. Add 0x squared as a placeholder. And then it's going to be like the same thing that we've done. And 0x squared. And off we go. What do I multiply by so that when I subtract, I get rid of the x cubed? Well, I can see it's going to be an x squared. Subtract, and I get 2x squared. Bring down the 4x. See, I'm speeding up. Are you able to keep up here? I hope so. What am I multiplying this by to get to 2x squared? Well, I see 2x. 2x times x is 2x squared minus 4x. That looks like that's going to cancel out, but it doesn't. 4x, subtract negative 4x is 8x. And then bring down the 2. And I can see plus 4. No, not plus 4, plus 8. Nice job there, Resto. Plus 8. 8x minus 16. And when I subtract, I get 14. Positive 14. Check with my notes, see if that's the same thing I got in my notes. Yes. And so my division statement, if I wanted a division statement, then I'd say, therefore, what I'm dividing by, sorry, what I'm dividing into is equal to what I divided by, the divisor, times the quotient plus the remainder. And notice that if I were wanting to graph this, this doesn't help me much because that's not an x-intercept. It doesn't work. So this would be very hard to graph. This one, we you know, it's like we failed at finding the starting spot. Onwards. Last one. Ooh, dividing by a quadratic. As we'll see, and you're going to come across some weird ones in the homework. If we just trust the pattern, everything works out great. So I'm dividing by this into a quartic. I don't need any placeholders. All is good. Well, what do I multiply by this thing so that I get rid of my first term? Well, I need to multiply by a 3 and an x squared. Well, where do I write the 3 and the x squared? 3x squared goes there over the other x squared term. And when I multiply, I'm going to be subtracting 3 things instead of just 2. So is that different? A little bit, not much. 3x squared times x squared is 3x to the exponent 4, and that's exactly what we planned, right? And the rest of the ones probably won't work out, and they don't. 3 times minus 3 is negative 9. X cubed. 3x squared times 1 is 3x. And see, when I subtract now, that one's gone, but I'm going to have 2 terms left over. That's still smaller than what I'm dividing by, though, so I'm not too worried or scared. Subtract. And then bring down. And now I have another trinomial that matches the trinomial I'm dividing by. What do I multiply by to get rid of the 7x cubed? Well, 7x will work. And then 7x times, numbers are getting big, makes me a little bit nervous, but I think I'm okay. And then onwards we go. Subtract. The first term's gone. 1 subtract negative 21 is 22x squared. Negative 7 subtract 7 is negative 14x. And this isn't going to be very fun to end, but that's okay. Because I'm multiplying by 22 to make this disappear. 22x squared. 22 times negative 3 is negative 66x. 22 times 1 plus 22. Then when I subtract, and something a little bit strange happens here. Get rid of the homework thing here just for a second. Move that down a little bit. Is that when I'm done, I subtract, I get 52x and negative 18. that I still have an x left in my answer, and there's no more terms to bring down. Is that allowed? Well, remember, our whole goal was so that what we were left with was less than, fewer terms than what we were dividing by, and so this all works. Okay, I'm going to write my divide statement. I'm going to just call that my polynomial p at x. Therefore, p at x is equal to my divisor. This is going to be a big long mess, isn't it? Times my quotient. I'm going to move this over. Hopefully, where can I move it? Yeah, I know I'm cheating. Plus my remainder. And as long as my remainder is in a smaller degree than what I'm dividing by, is fine. That's good. Divisor, quotient, remainder, that's dividing polynomials. Okay, and be patient there, folks. There's lots of places to make arithmetic mistakes. You will make arithmetic mistakes as long as you just accept that fact that you'll goof it up a couple of times and make, subtract errors and stuff like that. That it's okay. We want to get into the pattern and be able to find our own mistakes as well. So there are some for you to try. The book actually has a different way of doing this. It's called synthetic division, and it's on page 164 and 166. Technically, a little bit, it's a faster way, but it doesn't always work. Like, for instance, you couldn't use synthetic division on this last question here. But if you teach yourself that and use it on the test, you'll save yourself a little bit of time, and I'll give you a bonus mark for it. So this I'm not teaching in class or in videos. That you'll teach yourself if you like, and if you want to do that, show it on the test, and you'll get a bonus mark for it. All right. Good luck in class with the homework, folks. The thinking ones, try a couple of those. Those are basically some weird ones. So try a couple of those weird ones, and they're a bit of fun. All right, that's it.